Hi, this is a very quick introduction to the JBBRXG11 project, friendly name Jibber, perhaps JBBRXG11 or something like that. Our goal is to extend Microsoft's XNA 4, or somewhere between XNA 3.1 and 4, to support DirectX 11 features. It's built on top of XNA, replacing some of the graphics code, and accesses DirectX 11 through SlimDX. So I'll just show you through a small example program here which demonstrates the use of tessellation and a geometry shader. So this should be sort of roughly familiar here. It looks very much like an XNA project. So we have device manager and sprite batch and stuff. I've loaded one demonstration effect, one texture. There's a vertex declaration still hanging about because bits of our code are still XNA 3.1 like. First interesting part here is an array of 4 vertices of type vertex position texture, so carrying a texture with the vertex position. This just represents a square. There are no view or projection transformations involved here, so it's just a square which occupies the center quarter of the screen, direct and projection coordinates. The game 1 constructor, much as it would be in XNA, initialize doesn't do anything. If we scroll down a little bit, the load content does the normal sprite batch creation. I load the texture, I load the DirectX 11 demo effect, and there's only one parameter to the effect, which is, well, actually there's two. There's one parameter which I set here, which is texture. Later on we'll connect it to time and set up the vertex declaration. And that's pretty much it. There's just enough update to allow the program to exit, and the program, the draw section here, looks pretty familiar. I set the vertex declaration, I set the time parameter, which is just generated from game time, old-fashioned effect syntax from DirectX 3.1, sorry, XNA 3.1, and the graphics call here sends the 4 vertex position texture objects, but notice the new primitive type. It's patch list with 4 control points, which is one of the things that feeds into the hull shader. Okay, so essentially what I'm telling it is that I'm sending over one primitive, vertices.length divided by 4, and it's defined by 4 control points. They are actually the 4 corners of the square that I'm displaying in this case, but more generally they could be something else. Okay, let's have a very quick look through the shader. So 2 parameters provided, texture and time. I have a texture sampler. Basically all of the parameters passed from one place, and all of the vertex structures contain a position and a texture. Just the one that is passed to the pixel shader as an SV position as required in level 5 shaders. So just very quickly, if we come down a little bit here, we have the hull shader set to work on quads with integer partitioning, going to generate clockwise triangles with just 4 control points that will represent the corners. Has a patch constant function, which is just up above here. At this stage, the subdivision is programmed to vary with time. It runs from about 1 to 9 and back again. It applies to both the internal and external subdivision of the quad. Then a bit further down, there's the domain shader. Domain shader takes the output coordinates from the tessellation process and uses them to interpolate the position coordinates from the patch array and also the texture coordinates. To make the thing a little bit more interesting, rather than just displaying a subdivided square, we've added a geometry shader here. And the role of the geometry shader, probably not much reason to go into the little bit of maths here, but the reason for using a geometry shader is that it is given all three coordinates of a triangle, which means that it can find the center of a triangle, and I can offset the center of the triangle on a sort of sinusoidal path, and also rotate the triangle. This creates a small 2x2 rotation matrix, which means that rather than the components produced, little triangles produced by tessellation, we have little triangles that can wander off and rotate and do stuff like that. We output the coordinates here. Pixel shader isn't very interesting at all. You just take a texture sample, and you see at the end the shader model 5 technique 11 syntax, and it's set. We set the vertex, hull, domain, geometry, and pixel shaders. Okay, enough said. Let's run the sample. So there you see the original two triangles. Next iteration, we just break each one in half, move them around a bit, show their separate triangles. Not sure my laptop is coping with the screen recording all that brilliantly. Rotation doesn't look as smooth as it does without the screen recorder running. It cycles through up to a larger number of subdivisions. It's either 8 or 9 or something like that. And then it will go back to 0. But remember, from the point of view of the XNA program, which is very much in the style of Microsoft's XNA, just small extensions, we're drawing a single square with 4 vertices. Cool. Thank you.